Okay, welcome back, Physics 30. This is the last part, the part 2 of the graph matching booklet that I have. And key thing here is to write what I have at the top here. So depending upon where our position time graph starts, it could be a curve or it could be an increasing or decreasing straight line. And this kind of gives you an idea of how to move on to the VT graph and the AT graph. So of course the slope of the position time graph gives you velocity, and the slope of the velocity time graph will give you acceleration. So it's slope to slope, as I mentioned earlier in that other booklet that we had. So if we look at what the slope of a curve looks like, it's an increasing or decreasing straight line, as illustrated here. With graph B, the slope of various parts on this, as we saw, was an increasing straight line. Whereas the slope of an increasing straight line is simply a positive line or a negative, depending upon where it is. So the slope of a curved line gives us an increasing or decreasing straight line. The slope of that gives us a horizontal line, and of course the slope of that gives us 0. So that'll help us figure out where in fact we are. So I'm just going to use a couple of labels here. So PT, VT, and AT graphs. So we'll kind of figure out where our graphs fit when we look at them in these 8 questions. So if we look here, drove away from home with constant velocity in the negative direction. So you drove away from home, so your position is at home, and it's saying here constant velocity in the negative direction. So constant negative velocity would look something like that. Okay? So that tells us automatically that our VT graph is a horizontal line. Now our other graphs, our AT graph is going to have to be there, and our PT graph is going to have to be there. So you can see here the slope of that now is simply 0. And our PT graph, according to this, is going to be an increasing or decreasing straight line. Now, what kind of slope, what type of line will give me a slope that's a constant negative number? Of course, something that looks like this. A line that's going in the negative direction. Okay, so you can see how that fits in here. Figure out where our graphs fall, and then that gives us a little indication as to how to figure out how these work. If we look at the next one here, starts in a positive position, so I'll just mark that, and speeds up with constant acceleration, positive direction. So we're speeding up. We're not going at a constant velocity. It'll be a position time graph that's straight. But if we're speeding up or accelerating, that is going to be a curve. And since it says we're going in the positive direction, we're curving up. So our PT graph is a curve, which means our VT graph will be a straight line, increasing or decreasing, and our acceleration is a constant line because, yes, we are accelerating. It's not 0 acceleration, it's a constant acceleration. So if, just like before, so the slope in this section is 0, so that corresponds to 0 velocity. The slope, my curve line isn't that great here, but the slope here will be a small negative or small positive velocity at approximately that time. So at approximately that time we'll have a small positive velocity. And the slope here, the tangent line here, would be a large positive slope, large positive velocity. So it would be an increasing VT graph. And of course the slope of that is a constant positive acceleration. Okay. 3. Initially has a large positive velocity and comes to rest with constant acceleration. So we're not told where we start, so it doesn't really matter. Large positive velocity at the start and then comes to rest eventually. So that tells us that our VT graph is going to look something like this. Large positive velocity comes to rest. So our VT graph is a decreasing straight line. So our VT graph falls here. So it's going to be similar. Decreasing line, which means our acceleration is a flat line, and our PT graph is going to be a curve. The question is, in which directions? To get a large positive velocity, we need a large positive slope. Medium velocity, kind of a medium slope. Zero velocity, no slope. So you can see it's a curve that looks like this, and I kind of failed at connecting those points there. So slope of that gives us that, and of course the slope of this decreasing straight line is going to give us a constant negative acceleration. So here's the scenario. We're going in the positive direction, our velocity is positive, our acceleration is negative, so that tells us that our acceleration is working against us, slowing us down in the positive direction. Okay, I'll maybe go through this one with you and then let you do the ones on the flip side. So this one starts in a negative position, speeds up with constant acceleration. So that tells us right now that our acceleration has to be in this area. We have acceleration, so it's either positive or negative. It's definitely not zero. So our PT graph's a curve, VT graph's an increasing or decreasing straight line, and our acceleration has to fall there. So if we take a look, constant acceleration in the negative direction. So it doesn't tell us where we're starting, so it doesn't really matter where we have it. Heading in the negative direction. And of course the slope of that is a constant negative acceleration. So you can see our velocity and our acceleration are both in the same direction, so we will be speeding up. Over here originally 0, and speeds up, and now it gets negative, large negative, so negative, and large negative slope. So you can see it's a curve that's curving downwards like that. Okay, so that's what we have there. So I get you to try the flip side here, and then come back to part 3 of the video to see your answers, and we'll see how you made out.